Now we are ready to go over a few examples to help us how to solve projectile motion problems. Our strategy is straightforward. First, sketch the path. Second, resolve the initial velocity into its x component and the y component. 3. Treat horizontal and vertical motion separately. 4. In the horizontal direction, the motion is a constant velocity motion. 5. In the vertical direction, the motion is a constant acceleration motion with acceleration negative 9.8 pointing downward. This is the first example. We have a rescue plane drop a package shown as in this figure. The airplane is traveling horizontally at 40 meters per second at a height of 100 meters above the ground. Neglect air resistance. So there are 3 questions. Let's solve them one by one. Question A. Where does the package strike the ground relative to the point at which it was released? So after the package was dropped, what kind of motion the package will be doing? Projectile motion, right? So in the x direction, what kind of motion it is in the x direction? Think about this. It should be constant velocity motion. For constant velocity motion, we need to solve displacement in x direction. And we know the constant velocity in the x direction, which equals to initial velocity in x direction, which is 40 meters per second. So we need to find this t. We want to know how long that the package is flying in for this projectile motion, right? We also know the dropping height is 100 meters. If you recall in free fall, if you throw something from 100 meter tall, you can find what's the time it reaches the ground, right? This is exactly the time the package is in the air. So we need to find this t from the information 100 meter. So that's a goal. We need to find this from y direction. And in the y direction, so we know change displacement in y from 100 meter to 0 meter. Displacement actually is negative 100 meter in y direction. Initial velocity in y direction is 0 meter per second. Even if it's not given in the as number in this problem, we should understand when the package is just dropped, there is no velocity in the y direction for the package. And then of course, the acceleration in the y direction is negative 9.8 meter per second square. We want to solve t. So we need to go back to the kinematic equations. The best one to use actually is this one. And plug in all the numbers. Negative 100 equals to 0 plus 1/2 negative 9.8 t squared. Solving it give us t equal so the total time the package is in the air is 4.52 seconds. Now put it back into here. So the package hit the ground with a relative distance about 180.8 meters. Second question, what are the horizontal and the vertical component of the velocity of the package just before it hits the ground? So there is a x component of the velocity, y component of the velocity. Is doing constant velocity motion in x. So Vx equals Vx0 equal 40 meter per second, even here. This is still 40 meter per second, constant acceleration in y. So we need to solve what is Vy. And we know Vy0 is 0. We know acceleration in y. We also know t now from our part A, 4.52 seconds. So we can use the first kinematic equation. Negative means the velocity in the y direction here is pointing in the downward direction. Okay. What's the angle of impact? So this is our Vx, this is our Vy. Is actually asking, this is our V of the package, is asking this angle. So of course, from trigonometry, tan of this angle should be given by Vy in magnitude over Vx in magnitude. So this angle is given by inverse tangent and the calculator gives us this is the impact angle. Okay, that's the problem. We have an air defense cannon fires a shell at an enemy bunker located 5,000 meters horizontally from the cannon. The target is also at a ground level. The shell is launched with an initial velocity 250 meters per second. The launching angle is 45 above horizontal. So we have three questions. First, how long does the shell stay in the air? So we need to solve it the same way we did, right? First, we need to find our initial velocity in y direction, which is initial velocity times cosine 45. No, actually it should be sine 45 degree. For y component is sine 45 degree. How long does the shell stay in the air? So this is trajectory. The shell goes to the highest point and then it drops to the ground. And we can imagine those two times from ground to peak and from peak to ground are the same. So it'll be easier for us to solve what time it takes to the peak. Vy at peak would be 0 meter per second. So at the highest position, the velocity of the shell is entirely horizontal. There is no y component. So the y velocity, the velocity in y direction at the highest point is 0. Ay is a negative 9.8 meter per second square. And now we solve for t, the time for it reach peak. So we use this equation again. 0 equals to 176.8 plus negative 9.8 times t. Solve it. That gives us t equals 18.04 second. This, now remember, this is a time for the shell to reach the peak. So the total time is 2 times the time to reach peak. So it's 36.08 second. What's the horizontal range? So the time the shell move in the air is 36.08 seconds. Initial velocity in x direction is initial velocity times cosine 45 degree is 176.8 meter per second. So total displacement in x is Vx is a constant, so Vx always equals to Vx0. Roughly give us, okay, then it asks us whether we get the target. What do you think? So the shell landed this much away, and the target is 5,000 meter, 6,382 meter versus 5,000 meters. So the answer is no. Okay. So this concludes our example on projectile motion.